Good morning, everyone. Today's our topic is on transient response of RC series circuit in with DC excitation. In this, we are going to first find the voltage across the capacitor and current through the capacitor, and with and without inputs. In capacitor network or a circuit, we are focused on voltage because the energy stored in the capacitor is in the form of charge. So charge is proportional to voltage. So first we will be finding the behavior of the voltage. So for this, for first order RC series circuit, it will be in the form of at t equal to 0, the switch is closed. The voltage across the capacitor is Vc. The current flowing through is Ic of t. Because the series, the currents are same, so the current flowing through capacitor will be same in the current flowing through the resistor also. So initial voltage across the capacitor is 0 because the switch is closed at t equal to 0. Before t0 minus, the voltage build up across the capacitor will be 0 volts. Now applying the KVL, in the circuit. So by applying the KVL, we consider from here minus V plus R into Ic of t plus Vc of t is equal to 0. We know the current across the capacitor will be Ic of t is equal to C dVc by dt. This is the basic current in a capacitor. So we will reform it. R is equal to R Ic of t plus Vc of t is equal to V. Yes, I have written Ic is equal to C dVc by dt. I placed it here, and we will be interchanging and integrating this, and the final value I will be showing. Here interchanging Vc of t and dt after applying the integration on both sides, and we got 1 by V minus Vt into dVc is equal to integration 1 by Rc dt. This is the basic formula for this integration 1 by 1 minus x. For this, it is similar to this, so the value is minus ln of V minus Vc of t. After integrating constant, so t is multiplied plus k. To find k, we put t is equal to 0, and here the initial conditions are 0, so voltage at capacitor initially is 0. So minus Vc of z plus 1 by Rc of 0 plus k. Now we get the k value is equal to minus ln of V. Here from equation 2, this we are keeping in the equation 1. So we got ln of V minus Vc of t is equal to 1 by Rc t, as it is in the place of k we written ln of V. So by interchanging uh, all v's on one side and t terms in other side, we interchange it like this. We applied log a minus ln of ln b log a by b, that we have written here, and the ln, if you go here, it will convert to exponential, and the denominator v is multiplied here. At last we got v capacitive voltage as v minus v into e power 1 by rc of t. Let take tau is equal to rc. So now at instance of t is equal to tau, 2 tau and 3 tau, if you draw a graph based on this, it will be increasing exponentially. The maximum rise is at 0.632 times of v. The steady state will be v. This is first time constant, second time constant, fourth time constant, and sixth time constant when t is increasing. So from this it is clear that at t is equal to tau, maximum rise of voltage takes place. After t greater than tau or t tends to infinity, voltage settles to steady state value. Now current, from this we can derive the current IC of t is equal to C into dVct by dt. From this, C is equal to d by dt of v minus v e power 1 by rc of t. So if you differentiate it, 0 minus v into 1 by rc e power minus 1 by rc into t. C cancelled out, and minus v by r e power minus 1 by rc into tau. Minus minus, it will be plus. So IC of t. This is the current equation across the capacitor. Now we got the current equation. We will plot the graph based on this. As the maximum value is v by r, so it is when the time increases, IC of t, when the time increases, the value will be decreasing. So at tau 0.368 v by r, it is 2 tau, 4 tau and 6 tau. From this, it is clear that when t tends to infinity, IC of t will be 0 amps and VC of t will be V, that is maximum voltage. This condition is open circuit condition. So capacitor with DC excitation at steady state, it is considered as open circuit. Let's summarize. Voltage across a capacitor for RC circuit is V minus V e power minus 1 by RC into T. When if there is an initial, we will be considering the next step. Up to now, current across the capacitor will be V by R e power minus 1 by RC into T. Now RC circuit without source. Capacitor initially charged up to V naught. So Vc of 0 is equal to V naught. Now at t is equal to 0 plus, switch is closed. So the circuit will be looks like this. When you apply KCL here, KVL, so current direction we assumed in this forward direction, so plus R IC of t plus we consider it as Vc of t, as initial voltage is V0, but we are considering overall IC of t is equal to 0. So from this we will expand. We know IC of t is equal to C dVct by dt. We will be placing this and separating it and integrating it. So we know IC is equal to C dVc by dt. So we placing in our equation R is equal to C I of t will be replaced with C dVc by dt plus Vc of t is equal to 0, and we interchange it and applying integration on both sides. So after applying the integration, we got ln of Vc of t is equal to minus 1 by RC t plus k. To find this time constant at t is we taken the equation in t is equal to 0. At t is equal to 0, Vc of 0 is equal to V naught. So at t equal to 0, we are placing the 0 at t. So we got k value is ln of Vc of 0. Vc of 0 is nothing but V naught. Placing equation 2 in equation 1. ln of Vc of t will be minus 1 by RC t plus ln of Vc of 0. Vc of 0 is V naught. So from this, if we interchange the values and we consider this log m minus log a minus log b means log a by b. So we need to find the Vc of t. So remaining terms we place it that side, and we finally obtained the equation Vc of t. The voltage across the capacitor is V naught e power minus 1 by RC into t. That is without source. So it is exponentially decreasing. The voltage is V naught, initial voltage, and this will be the 3.68 V naught at t, tau, time constant, and 60, so on. This is the voltage across the capacitor. So at t tends to infinity, the developed voltage Vc of t is equal to V naught will be equals to 0. Now we will find the current Ic of t. Ic of t will be C dVct by dt. In this we will place our equation. See, from here we will place the equation here, d by dt of V naught e power minus 1 by RC into t. By doing this, Ic of t will be minus V naught by R into e power 1 by RC into t. From this equation, Ic of t is minus V naught by R e power 1 by RC of t. From this, the waveform will look like this: minus V naught by R. This is the first time constant. This is the second time constant. So on. So t. This is Ic of t. From summary, we can write without source Vc of t will be V naught e power minus 1 by RC into t, and Ic of t will be minus V naught by R into e power minus 1 by RC into t. And another formula, summarizing the formulas with another formula, like we can generally write Vc of t will be final plus final minus initial into e power minus 1 by RC into t. This is the standard formula. This is similar to earlier we derived the formula that Vc of t is V plus V minus V naught e power minus 1 by RC into t. Here in our case this is 0 at initial stage, so we took this as 0, then that time we got V plus V into e power minus 1 by RC into t. So we taken this as a standard equation. In this question they gave the circuit behavior like this: at V naught it is going and it is crossing the zeroth axis at 0.4 tau, and here another charged voltage at initial voltage is V naught dash, it is crossing the zeroth axis at 0.2 tau. So they are asking, this is an RC series circuit, that means this is an RC series circuit with R and C, 10 volts as an input volts, and V naught is also 10 volts. What is the absolute value of percentage change required in the initial capacitor voltage, that is V naught, required in the initial capacitor at 0th crossing happen at 0.2 tau. That means they are asking the absolute change, that is all positive values, difference between these with respect to the 0.4 tau initial voltage. So first we need to we write the standard voltage equation. This is final voltage plus final minus initial into e power 1 by RC into t. So they are talking in tau, so RC is indirectly a tau value. So RC is equal to tau, we consider RC as a tau, and we are placing t is equal to first value, we are placing 0.4 tau. So we will rewrite the equation as final value, it will be directly 10 volts as it is connected to 10. Plus we don't know the V0 here. Sorry, this is input voltage. Final minus V0. V0 is the initial voltage across the capacitor minus 1 by this RC is a tau, and we are applying at T 4.0 tau. Tau gets cancelled out, and at 0.4 tau the value of Vc of t will be 0 only. So 0 is equal to 10 plus 10 minus V0 e power minus 0.4 will the value will be 0.670. So by interchanging the V0 we got as minus 4.925 volts. So this value we got as 0.4925 minus. Now we need to find V0 dash. So we consider the same equation, and tau at 0.2 tau. So Vc of the here also the Vc will be 0. The final value is 10 plus 10 minus V0 will be V0 dash now into e power minus 0.2. So here this is 0, 10 plus 1 minus V0 1 e power minus 0.2, the value will be 0.818. So from this V0 dash the value will be minus 2.224 volts. So the absolute percentage change, absolute means we need to take the positive values itself, as it is a negative, but we will consider it as positive. 4.925 minus 2.224 by with respect to 4.925, the value will be into 100, the value will be 54.87%. For this question, in the circuit, a step input voltage is 5 volts is applied at point node A at t is equal to 0, as this is the input waveform. The capacitor initial voltage is 0, so the capacitor is not charged. The voltage at node P at t equal to 6 microseconds. So for this we will write the final capacitor voltage, final value plus initial minus final into e power minus 1 by RC into T. So first we need to find final value of capacitor voltage, final value of Vc of Vc, that is final value after t greater than 0, the circuit will be direct 5 volts is applied. We need to find the capacitor voltage, so we can use Thevenin's voltage, voltage, open circuit voltage, Thevenin's and 2 ohms. So the Thevenin's voltage is same as 3 kilo ohm voltage. So VTH will be total voltage is 5. This is same resistor by sum of resistors 5 kilo. So this one 5 will be cancelled out. VTH will be 3 volts. So final value of capacitor voltage is 3 volts. Now initial value they given as 0. So V0 is equal to 0. The RC, we need to find RC. R is now to find the R we need to find R, and C is given 5 nanofarads. So to find R we need to find RTH value, Thevenin's voltage, Thevenin's resistance from this circuit. So we need to short the voltage source, and we need to find the RTH value. 3 kilo ohm, 2 kilo ohms RTH. As these two are parallel, RTH will be 2 into 3 times of this is k square by 5k. Now the value will be 6 by 5 kilo ohm. So RC value will be 6 by 5 into kilo into 5 nano. Overall it will be 6 micro. RC value will be. Now they are asking at 6 micro. As I think this is the first time constant. What is the value of VC? VC of T will be final value. What we got is 3 volts. 3 plus initial value is 0 minus final value 3 e power, as it is the same time constant at first time constant, then it will be minus 1. So 3 is taken as common, 1 minus e power minus 1. So the value will be 1.896 volts. For this question, we need to find the time in milliseconds required for the voltage across capacitor to drop to 1 volt. So the capacitor is charged to 100 volts. To get 1 volts, what is the time taken for the capacitor? So from this given, C will be 0.1 microfarads and V0 will be 100 volts and resistor will be 1 kilo ohms, and we need to find time at VC at 1 volts. So from standard equation, VC of T is final plus initial minus final into e power minus 1 by RC into T. We need to find this T. So final value, we wanted the voltage at 1. So final value the final value will be, as this is a source free circuit, that means it is already charged and discharging through a capacitor and resistor in series with the resistor. The circuit will be like this. So the final value will be voltage will be decreasing to 0 plus initially they given 100 volts minus final value will be 0 e power 1 by RC. RC into T. So RC value will be, R is 1 kilo, C value is 1.4 micro. Then overall it will be 0.1 milli. 0.1 milli. So 1 is equal to 100 into minus 1 by 0.1 milli into T. So by interchanging 100 goes here, the time will be, that means 1 by 100 exponential come here, it will be ln is equal to it will be minus 1 by 0.1 milli into T. Now the time will be 0.46 milliseconds.